Okay, let's calculate Gibbs free energy. So you will need an equation for Gibbs free energy, and the change in Gibbs free energy is equal to the change in enthalpy minus the temperature times the change in entropy. And so this is temperature. Make sure you have that. Needs to be in units of Kelvin. All right, and so the reaction spontaneity in part depends on the temperature of the reaction. What temperature is this reaction taking place at? And so that's an important thing that we'll get to and talk in a lot more detail about in another lesson. So anyway, this is your formula for Gibbs free energy. You need to know this formula. So delta G equals delta H minus T delta S. And so let's do an example problem. Okay, so here's an example. What is the change in Gibbs free energy for this particular reaction at 25 degrees Celsius given the enthalpy of the reaction? So the change of enthalpy for the reaction, should have that there, and the change in entropy for the reaction are these two values. Now, I want to point something out to you that's very important, and if you don't pay attention, you'll make this mistake. Looking at the units of the enthalpy, this is in kilojoules per mole. And for the entropy, this is in joules per mole Kelvin. You need to make sure that these are in the same units. So most people will multiply, will convert the joules to kilojoules. So if you do that, you'll simply move your decimal over 3 times as you divide by 1,000 to convert joules to kilojoules. And so if we redo that, this would be negative 0.4095 kilojoules per mole Kelvin. So make sure that you correct the units for either the enthalpy or the entropy. The standard is to correct the entropy to enthalpy. Okay, so let's take it, and at this point you're just plugging into an equation. These are not difficult. It's just algebraic solutions in equations. And so the change of enthalpy is negative 160.8 kilojoules per mole. And we're going to subtract the temperature, which needs to be in Kelvin because the unit over here is Kelvin. So 25 plus 273 makes 298 Kelvin. And that's going to be multiplied by negative 0.4095 kilojoules per mole Kelvin. So just bring this one down, 160.8, negative 160.8 kilojoules per mole, and minus, and you multiply these two together, the 298 times the negative 4.095, you get negative 122.031. The Kelvin cancels the Kelvin, so that leaves you kilojoules per mole. And minus a negative means we're just going to add, so we're going to end up adding these. So add negative 160.8 to 122.031, and that gets you negative 38.769 kilojoules per mole. Okay, and so if we round that off for significant digits, I think that'd be negative 38 point. We had 4 here, 4 there, so 38.78. All right, now, is that spontaneous or not spontaneous? The sign of Gibbs free energy is negative, therefore this is a spontaneous reaction as long as it is at 25 degrees Celsius. If we change the temperature, then that can change this number here, which could hypothetically flip this sign, and we'll talk a lot about that in the next lesson. And so that's a spontaneous reaction, and that's how you can do simple Gibbs free energy calculations.